Hello engineers, makers, electronic enthusiasts out there. We are back from Aachen, Elektor Lab Talk. This is Mathias Claussen.
Our editor-in-chief, Jens Nickel. So welcome to those who have tuned in.
Matthias, why do we have headphones today?
We have a guest.
Yes.
And yeah, as we are afraid of having some sort of echo and feedback, we wear headphones so we can hear him. You will also hear him, and we avoid feedback loops in an unwanted fashion.
Okay.
So no strange beep sounds, hopefully.
Today's show overall subject is the heat, or electronics and the heat.
Yep.
So it's a little bit more comfortable here in Aachen.
Yeah.
It's about 23 degrees, something about this. But
the weeks before it was a little bit warmer,
yes.
So sort of summer circuits.
Mm-hmm. Yeah, we will come later to this issue. Let us begin with the winner of the last show.
Yeah, that's Martin Werner. He has won a Wellerman PC oscilloscope, the PCSU01. Congratulations for that one. Our logistic teams should already be in contact with you. And yeah.
Congrats.
Should we say what the people can win today and why?
Of course, we do.
Would we show them what they can win? I mean, we have it here.
Yep.
So we are giving away 5 Elektor US style Siren kits. We have one on the desk. If you switch to the side camera at that point.
Of course.
So no short circuits. This is a nice educational kit that will produce the 3 most common US siren style sounds. We have the ambulance, police and fire department. So if you insert a coin cell, and we haven't inserted a coin cell and running on a power supply, so that we don't waste non-rechargeable batteries with this circuit just for having that shown here. So sort of some modifications with the wires, but it's a nice kit. If you insert the battery and don't press the button, it won't discharge the battery. So the battery stays disconnected, but nevertheless, if you don't have to use a chemical cell, why not? You can switch through the sound it can make. It comes with its circuitry printed on the PCB, and on the back side you also have some background on the circuitry. It's also featured in the Summer Circuit edition, if you like to read a little bit more about it.
Yes, that's our edition we currently have at the newsstand sales. The members already got their copy, of course. Yeah, you can see the Summer Circuits are back. Summer Circuits 2022, and in former years we had this traditional semiconductor guide. So that's a sort of follow-up, full of small circuits and projects and so on. And as you know, I'm not the best one learning by heart, but I can tell you some of the projects. We have 2 rotary encoders, a digital 220 volt dimmer current source for LEDs, detect 4 switches with 1 pin, a simple electronic organ, a mains filter, button-free door control, DI box for a smartphone, 1 button thyristor control, an analog tanning timer, and. So yeah, I think it's worth the money if you go to the newsstand sales, or you can also get it, of course, in our Elektor shop.
If you want to win it, we have to tell maybe 1 or 2 words more about it. We have a register page to enter the contest. We can show that one. So may our colleague can put the link in the chat. Hope she's listening. There is one thing that has changed. As you can bookmark the page and would be able to just not attend to the stream and nevertheless get a giveaway, you have to enter a keyword for this one, and this time it's Lab Talk. All small letters. If it asks for a keyword or passphrase, enter Lab Talk, then you should be good to go.
So Matthias, I think it's time for our small intro.
Yes, we have again a sponsor, and from the category It Works So Nice, they did it twice. Today's episode is sponsored by Joyet. Joyet is the supplier for maker and professionals with a broad range of products from modules, accessories, education kits, measurement devices and test equipment up to individual electronics development. We can sure Joyet will have a solution for your electronic needs. For this or for their product catalog, service and distribution partners, check out the link in the description below. And today's featured product from Joyet is the RD6006, their power supply, something we also use or currently use to power our Siren board. You can enter voltage, current limit as you like, with a lot of more features to discover, like Wi-Fi interface for automated control, available as said at the Joyet distribution partners, for example the Elektor shop, and also coming up a Joyet product, the DMSO 2D72, which is their 3-in-1 handheld measuring multimeter oscilloscope. You can also find in the Elektor shop, and I've been told there may be an action for this product in the upcoming days. So take a look, take your thoughts, and if you like it, you know where you can buy it. So that's for the sponsor of today's episode. And let me see if in the chat, yes. So I've just seen that the link for the giveaway is dropped in the chat, also the code word, use it, and I wish you the best to be one of the 5 winners of this Siren kit. It's really enjoyable to solve it, and it's a really nice circuitry.
Yeah, Matthias, we just talked about the summer circuits, and you also made some summer circuits. We already mentioned that electronic dice, and I think the other one was DC-DC booster.
Yes.
Yeah, it is always hard work for the whole team, and yeah, we said in previous months we really need additional help, and additional editor is heavily needed.
Yes.
And yeah, finally we found one.
So
and
let me just move that over. So yes, we have gotten support from mostly like the neighborhood, you can say.
At least it's the same time zone, so we don't have problems with calculating all the time.
Yeah. So may have a warm welcome for our new team member, Brian Tristian Williams. So yeah, may unmute him. I see the red light still.
Yeah, I always forget this. Yep.
Hi guys, how you doing?
Fine, thank you. How are you doing here in South Africa?
Well, it's winter here and it's summer there, and I think the temperature's about the same at the moment, about 22 degrees, but you guys have had a heat wave that I'm glad to see you coming out of. What's
the temperature in summer in South Africa?
Oh, in summer it will be between 30 and 40.
Okay, 40 it's tough. So do you have air conditioner in the house? Is it common?
People don't have aircon in their homes, but definitely in offices, because you're expected to get your job done somehow.
Brian, you know Elektor since many years because you already did books.
Yes, I've done some work for Elektor on and off, translating books from German and Dutch and doing editing, but I go back far more as a customer. I bought my first Elektor magazine in September 1990, and it was specifically to build this project over here. But it was a two-parter, so I bought the October edition as well. And quite coincidentally, we have a project coming up in November for the Fortissimo amplifier, and it's based on this medium power AF amplifier. So I think that was good timing.
Yes. So yeah, November, December, we have a cover project from our colleague Ton Giesberts. It's the power amplifier. Yeah, and there you can also have a kit. Again, an analog amplifier in Elektor. Yeah, we currently finished the cover edition. Brian, we both yesterday, and yeah, today we made a layout. It's 15 pages long, so it will be a long story, but it's interesting. There are a lot of technical details. Brian, as a subscriber, you also got the Summer Circuits. Are there some projects which you really like?
Well, I like the simple stuff. So here in South Africa, we do have some unclean power at times, and we've got an external mains filter here, and it uses only a handful of passive components, and you don't have to plug your device into it. It plugs straight into the wall outlet, and it filters your power and gives it some clean power. And then, of course, if you're like me and you've collected a bunch of infrared remote controls over the year and you'd like to perhaps use them for some other project, but you don't know if they work, this device here will give you an audible and visual indication of whether your remote controls are working when you press the button. So that's quite useful. And then, of course, this is not a circuit, but I'm a sucker for retro computers. I like Jan Boyting's article here on the old 1977 Elektor SCMP computer. That was pretty cool.
Indeed, I think you are not the only one who really likes these retro pieces of Jan Boyting. We will have more of it in the next editions. Yeah, coming back to you, Mathias, our main subject is electronics and the heat. So do you think people will have more attention on their electronics projects because the ambient heat is higher than before?
I mean, for the industrial projects or products you do, you have an extended temperature range, so 85 degrees in that area. But nevertheless, one problem you have, whatever you build, it will produce heat, and you have to get it away. So it means while your product may run fine at 30 degrees ambient temperature, if you have something that's outside in the pure sun and gets heated up beyond that, yes, so you have to sometimes rethink your product, maybe just change the color of your enclosure from black to something non-blackish, white, silver, that reflects the heat as good as possible. And also you have still to be careful what you choose and how you construct your cooling, because it's not like, you have to run in sunny conditions. And as for now, the times where you can say, okay, summertime at 30 degrees, that seems to be over for maybe a long time. I'm not sure if we can fix that or who will, but yes, so it's not that it's getting colder soon, but we have to think for electronics that can even run on hotter ambient temperatures. And if you think, for example, you have the outdoor DSLAMs to get your broadband internet connectivity here, and you have the sun shining on those, you may have the days where your internet connection drops because just your equipment on the street gets overheated. And that's also for other electronics. Whatever you do in terms of smart metering, smart monitoring, you have also to think that the room temperature you are working with is not 25 or 28 degrees anymore, so you are working with 36 or something like that. And yes, that's something we have to keep in mind. So that will be a challenge, not to forget that it's not getting colder at the moment.
Just for me as a background, for example, if you have consumer devices as these Bluetooth boxes, the people go with them to the beach and so on. Are there different chips in there than in normal electronics?
For those, you can mostly be assured that those are built to the consumer standards. And there is something that's even worse. It's not the electronics that can get you in trouble, but also in those portable thingies, there are batteries or lithium ion or lithium polymer batteries inside, and they don't like heat. They don't also like to be operated in a cold environment, but they also don't like to be heated up to over a certain amount of degrees, and it will at least shorten the lifespan.
Okay.
And also, if you have a nice black boom box, you're going to the beach and put it in the sun, the question is what comes first, that your enclosure melts, that your battery catches fire, that your electronic will fall apart. So for those things, read carefully what they are built for. And putting something black in the sun is definitely a stress test. So if you build, for example, a car, what they have done in the past, take the car, put it in Death Valley, high noon, let it sit there for a while, and if it is not melted and still operates, and it has to operate, and temperatures get really, really high, then then it's okay. So that's one of the oldest, or one of the oldest stress tests. You now do it with thermal and thermal cameras in a more controlled environment, but that was used back in the days. And that means if you have a black bonnet, your electronics will definitely heat up 60 degrees plus and need still to operate. But for automotive, you have other temperature ranges you need to operate in. So there are you at, I think, 125 degrees Celsius plus and minus 40, I think. So in that range, your electronic must work reliable.
You mentioned that the internet reliability could be an issue. Do you recommend that people have a backup system in the future?
The more interesting part is how to deal with the heat. I mean, it's energy. It's free energy, and at this point we don't want to have it. It's not like in the wintertime where you would like to have free energy, so to get still warm. And maybe for some things that are really important, you should have maybe backups. But those are then mostly medical, because you can survive without internet.
Yeah, of course.
Sort of. Fridge and stuff like that, that's a different story. And I think the most thing where we don't have a backup is the power grid itself. I think Brian can tell a little bit more about failing power grid.
This would be my next question to Brian, yes. How is the situation in South Africa, Brian, with the grid and internet reliability?
The internet's pretty reliable, especially since we're running fiber. Problem is, if your power goes out at home, you still need to power the router. So you need some sort of backup plan for your electricity. And a lot of people are buying what they call inverter kits, lead acid battery with an inverter, which will keep your power running between 2 and 8 hours, depending on what you buy. And if you own the house, then you could probably add a few solar cells to that to keep everything up and juiced up. But for now, those inverter kits, they are powered by the grid. And when the grid goes down, it switches over immediately to backup power.
Is this sufficient to have backup some hours in South Africa, or are there even worse breaks of the grid?
There are sometimes worse breaks, but those are few and far between. What they regularly have is what they call load shedding, because they can't keep the grid powered up sufficiently to handle all the heating and or cooling requirements, depending on whether it's summer or winter, and whether the coal gets wet because of rain. So they will switch off certain areas on a schedule and other areas at a different time. And we have a schedule, so we know more or less when it will go off.
Okay, so you are warned in front of?
Yeah. And typically that shedding will last between 2 and 4 hours. So if you've got a 4 to 8 hour inverter, you can get by and carry on working. Otherwise, it's off to a coffee shop with a generator.
We have another colleague that has to do that sometimes to get to the coffee shop.
What is the situation regarding solar cells? You already mentioned it. Do you see a lot of them on private houses or on the landscape? Are there bigger systems?
Yes, it depends on, as I said, whether the people are renting their homes or own their homes. People who own homes often have solar cells. In fact, I have a friend who powers his entire house off the grid, fully solar,
Okay.
with deep cycle lead acid batteries. And, they've had those occasions where the power would go out for days because of some malfunction.
Okay.
And it was nice for them to be the only house on the block that was fully functioning and fully electrified throughout the mini
So
crisis.
he had many friends at that time.
Yeah,
We
probably
have
using up space in his fridge.
we have a question from the chat. Do the electro engineers use smart technologies at their homes to monitor temperature, humidity, and stuff like that, or surveillance stuff?
Yeah, Matthias, you are an engineer, so do you have any sensors, home automation?
Inside the house, we have just simple RF temperature and humidity sensors that are reporting back to a kind of weather station. Outside, we have a modified electro weather station that's transmitting temperature, humidity, wind speed, wind direction over LoRaWAN back to the server inside the house over the LoRaWAN network. So we can monitor that and see how it is outside, how it is inside. Is it wise to open the window or not? So yes, that's what we're doing. And for the devices, yes, they are currently consumer grade. So they work. And for the weather station, the main electronics is not directly pointed into the sun. That's in a shadowed place, so it doesn't get heated up that much. So that's for my installation at the moment. Currently at the moment I'm more hunting for standby power consumption to get that lower. That's another reason. Yeah.
And Brian, did you build any automation projects in the past?
Well, yes, I actually have a bathroom scale that I hacked back when the ESP8266 first came out.
Okay.
And there was very little documentation on it, but I wanted to try it out. So I used an Arduino chip and the ESP8266 with 8 AT commands.
Okay.
Stuck it in an existing bathroom scale, added an RGB LED for feedback. Did not change the operation of the bathroom scale at all or interfere with the LCD display. So if your internet's down, it carries on working. But it's been almost 7 years now. It's still putting the data into the cloud, which is good. That was my first IoT project.
So you see if you lose weight on some app or?
I don't think that's ever happened, but I see if I gain weight. Yes.
Okay.
I've got a small PHP program on my own server that captures the data and shows graphs and emails me.
Yeah, but yeah, for the electronics outside, yeah, I have to be aware that it's getting warmer, and I have to take care that I don't overheat. So maybe the weather station needs a small redesign.
What can you do more? Can you have more ventilation in your housings? What do you recommend?
At the moment, may I need to clean up the enclosure so that it's a little bit brighter and reflects more sunlight. That's the first thing to do. Cleaning sometimes helps. So, and for the electronics, I need just to check in which range I can operate them. So, yeah, may I need to change those to a little bit more robust specified ones to make it, maybe a little bit future-proof.
Can you get chips which are automotive grade as good as the other chips, normal chips, and what are the price differences?
Can you get one? Are you talking general, or are you talking current market conditions?
First generally, and then in our special times.
Yes, technically you can get automotive qualified stuff in usual times. Currently, if it's good for automotive, it's sometimes hard to get those. I mean, currently it's hard to get anything that's interesting.
Yeah.
So, yeah.
There's another question in the chat.
Question is about the electronics, if they are peer-reviewed. So if there is a second pair of engineers' eyes looking on the circuitry. Depends, sometimes. If it's something really small, like just resistor, LED, power source, no. Then the second pair of eyes are the translators that are also technically really, really good. So we get even from our translators sometimes the feedback, hey, are you sure? Should it be that? Or, yeah, so sort of. But there are sometimes parts that go through that maybe just are
Happens, yes.
fully overseen or not considered during the design. And yeah, if you have more than a few hundred external engineering eyes looking on the circuitry, there is feedback coming in, like, hey, why did you do that? Or that's not...
Yes, but some things are just discussable, and some things are even just matter of taste.
Yeah, so that's something in.
It's like software coding.
Yes, I mean, there were things where circuitries did not work as expected, and that gone through, so yeah. But usually if we have built them ourselves, we made sure that it works.
But okay, we have to say decades ago it was worse at Elektor. You always had to buy the following numbers, following editions.
Yeah, but it's been improved.
Mm-hmm.
And the interesting thing is with, I mean, if we look at the Siren, that's THT components, it's really, really simple. But the higher the integration of circuitry is, the higher the speeds get, the more likely is that even an valid schematics can have problems on a PCB. So, like interferences, high frequency ones, capacitors that are designed on the edge. So yes, your mileage may vary in that respect, but usually circuitries, if published, should be in working condition, and if not, there should be a correction for that following.
Another question. Is it more about motors?
Mod D.
Recently articles titled Mod D have been published.
Haven't read that, seems to. Or if you if the chat can clarify which one are meant in the edition, it would be helpful. So
Maybe your motor control article?
Question. For me, if the title is English or German, it's quite easy to get what it is. If it's Dutch or Zone D articles, does it ring a bell?
Yeah, I know, yeah. Developer zone articles. Yes. Yeah, we have in every edition one developer zone article. Yes, that's zone D, yes. In French. Yes, from Clemens Valens. So we get contributions from readers about interesting developing subjects. Yeah, and Clemens is reporting on it. Sometimes also things he discovered himself or he wants to teach himself. And yeah, that's a nice. It's a nice idea to bundle this in a special or a book.
Yeah,
we will. Yeah, it's welcome, these ideas. So we can forward it to our colleague. Why not?
Yep. Brian, another question. Did you have a chance to read through the Summer Circuits edition?
Yes, I did. That's some of the articles I gave you at the beginning of this thing. And I must say, it is a pretty hefty magazine, so I haven't been through it all, but the stuff that I've been through, I've enjoyed, especially the infrared go, no go. Being able to hear your infrared remote control instead of having to pull out your cell phone camera or something that can see infrared.
Yeah. So, yeah, but it means you have some pages to go.
Yes, definitely.
So, what's next? We have, electronics and temperature. Oh, there's another nice thing about hot circuits. If you have an LDO installed in your circuit design, do some calculations about the heat and power dissipation you have to take care. There is an TI PDF that also has some nice tips and tricks around that. So how to calculate the amount of area you need to cool your LDO sufficiently. And yeah, if your ambient temperature increases, suddenly you have to use more PCB space or a heatsink.
Okay.
So, and that even for smaller currents and our let's say usual voltages. 12 volt in, 5 volt out, 7 volt lost, half an amp, gets warm.
Do they assume in the data sheets the usual room temperature, 22 degrees or something like that?
You have for those for almost every chip. If they dissipate power, you have something in the datasheet where it says how many power they will be dissipating and how much they will heat up on the other side. So you can calculate what you need to do to keep it cool. So yeah, that's something you have to keep in mind, especially if you use your MCU. It's quite interesting if you clock that to its absolute maximum, how much losses you have and how it gets if you clock that just half a speed, or if you're able to reduce the clock and also reduce the voltages your CPU or your MCU uses, how you get away with that. First, maybe longer runtime on your primary cell, and maybe also less heat dissipation. So yes, it's not like just going full throttle all the time. So saving energy means also saving heat dissipation. That's quite nice. As said, for the LDO, you can get really easy to a point where it will hopefully do a thermal shutdown, or it will just disintegrate. What comes first? And what quality grade you got? A colleague of mine said, hey, if you have components that are hot, place it on the underside of your PCB. So if it gets too hot, it will just fall down and you can see later what it was.
Okay.
Especially for power MOSFETs.
Good idea.
Yes,
I guess that depends on how your circuit board was designed.
Yes, he designed
Mathias, you're a fan of KiCad, and I saw that not all of the articles in the Summer Circuits edition are projects. It's actually a useful guide to KiCad, which is interesting reading and a good tutorial. If you guys should check that out if you want to design a circuit board and not have to mount your components underneath so that they don't fall out.
There's another thing with KiCad. You have a lot of predefined footprints. Look at the vendor's datasheet. Sometimes there are special hints in the datasheet how you can improve or how you should do your footprints, especially for SMD components, to get a better heat transfer from your component to the PCB or to a heat sink. So yeah, it's a wise idea not just to trust the common footprint you have in your PCB layout program, but also look in the datasheet what the vendor recommends you should do. So
yeah,
it's a nice hint to design hopefully working circuitry. Yes, I prefer to use KiCad. Started with Eagle version 6, so the last non-Autodesk version. The nice thing about that was it was running also on Linux. And yeah, after it became a subscription-based model and KiCad became much more usable from version 4 to version 5 and now from 5 to 6, so that you can do your daily designs with it. Depends, of course, what you do. If you do 8 or 9 layer PCB with special requirements, can get a little bit rough, but yes, I prefer to use KiCad. So we have colleagues that prefer Altium, so yeah, they do that part, but that's not my tool of choice.
There's a question about gallium nitride.
Our Stuart had it in the Engineering Insights, I think episode 3 or episode 4 of Engineering Insights that talk about those technologies. So go to the Elektor YouTube channel, look for the Engineering Insights, and it might be a really nice talk to hear what Stuart and his guest were talking about those technologies. So yeah, maybe we at some point we will have to need to, depends. But there may be more stuff coming up with the latest inventions. Yep.
Okay, when will be the next lab talk, Matthias?
That's that will be the 20. Or don't get that I got wrong last time. So there's a slap period. I think 29th of.
You are right.
September.
Yeah.
At that point, and yeah, it's the same. Will be the same time. We are not sure what episode 7 will be named, so that's to be done.
Surprise.
Yeah.
Just like the code word, make it a surprise. Don't give any hints.
Let them guess. No, we don't do that. Yeah, we will see with the code word if that's not working as intended. We will have another solution coming up. So yeah, so the next one will be the 29th of September. There will also be a giveaway. Also to be determined, but it will be announced before on our usual social channels. And at that point, to don't miss the episode, may hit the subscribe button. If you like Lab Talk, give us a like. If you don't like it, may hit the dislike button, but it would be really helpful if you write what you don't like, so we can improve on that. So constructive criticism underneath the videos is really welcome. We have some more shows coming up. This is the Engineering Insights number 9. That's the 21st of September on YouTube and Twitter. And we have a webinar coming up, charging batteries from solar. Might be interesting for Brian. With our colleague Clemens Fallens. You can join on Click Meeting. So the 28th of September. I think that's for the current shows.
That was it for today, I think. Yeah. Brian, thank you for being in the show. I think we will have you more often from now on here in the Lab Talk.
Great, I look forward to it.
Yep, maybe, hopefully at some point even in person.
Yeah, that would be great. I will be in Aachen in early September, but unfortunately not on the 29th. So we'll have to look forward from there.
So
maybe you can make a video.
Yes, maybe something like that. So as said, may hit the bell to get notifications. Maybe just start a stream spontaneously. Who knows? We will do our best. And Yeah, with these words, it's time to come an end. Have a nice evening. Enjoy the hopefully cooled down temperatures.
Well, it's winter here, so I reckon it will be pretty much colder going into this evening.
Yep. Then
Bye-bye.
Cheers.